Have you ever felt overwhelmed trying to understand complex algorithms like Monte Carlo Tree Search? You're not alone. Today, we're diving deep into how Monte Carlo Tree Search works, and I promise by the end, you'll have a clearer understanding. I know how frustrating it can be to watch video after video or read paper after paper, only to still feel lost. Many learners struggle with the details beyond the high-level explanations, and that's completely normal. Let's look at the specific questions that have come up. One user asked about the selection phase of Monte Carlo Tree Search, wondering where the child nodes come from if you start with just a single root node. They also questioned how the expansion and simulation phases fit into this. To understand this, we need to break down the phases of Monte Carlo Tree Search. In the selection phase, you start at the root node and select the highest scoring child node. But how do those child nodes get created? Let's explore that. And stick around. I have a great analogy at the end that will help solidify your understanding of these concepts. To understand how Monte Carlo Tree Search works, we start with the selection phase. In this phase, the user selects the highest scoring child node of the current state. Initially, the tree begins with just a single root node, but as the algorithm runs, it generates child nodes based on possible actions. Next, let's discuss the expansion phase. During this phase, the user adds new child nodes to the tree. This can happen by selecting a leaf node and expanding it, which means adding one or more children to that node. The user can also choose to add a sibling to an existing leaf node instead. Now, we move on to the simulation phase. In this phase, the user employs a stochastic policy to simulate the game. This means that the algorithm randomly selects legal moves for both players until the game concludes. The stochastic policy can be thought of as rolling a dice to choose moves. After completing the simulation phase, the user returns to the selection phase and repeats the process. By iterating through these phases, the user constructs the tree to a certain depth. The child node with the best score is then selected as the next move. Finally, the user should consider the responsiveness of their AI. The size of the tree constructed during the process affects how quickly the AI can make decisions. A larger tree may provide better decisions, but can also slow down the game as it requires more computation time. Fun fact, the Monte Carlo method was originally developed for nuclear weapons research. Now it's used in everything from AI to finance. Now, let's look at the answers provided by other users. This user explains that Monte Carlo Search Tree, or MCST, works by trying many random simulations of possible moves and keeping track of which move leads to the best outcomes. The root node represents the current game state, and its children are the possible moves you can make. If there are no possible moves, MCST isn't applicable. In a two-player game, the tree alternates between your moves and your opponent's moves. The traversal of the tree should be random, and after simulating a set number of moves, you evaluate which move resulted in the most wins. This process is repeated each time it's your turn, creating a new tree based on the current game state. Here's that analogy I promised. Think of Monte Carlo Tree Search like a game of chess. Each move opens up new possibilities. And just like in chess, sometimes you have to explore different paths to find the best strategy. And there you have it. Monte Carlo Tree Search is a powerful tool for decision-making. Keep practicing, and you'll master it in no time. If you found this video helpful, don't forget to subscribe for more insights.